Here we have an example that will involve the linear speed of an object. That's what we're going to try to find. So let's see what's going on here. A fly is on a record as in the record of a record player, if any of us remember those things, or you might be a high fidelity, low fidelity sort of person, and maybe you have a record player that you make use of. More power to you if that's the case. Anyway, a fly is on a record that is playing at 33 1/3 revolutions per minute. So that's the standard playing speed for an old record album. If the fly is 5 centimeters from the axis of rotation, then find its speed. And if we want to say its linear speed, to make sure we're talking the old style quantity and not the new angular speed, we can throw that word in there to clarify. Then find its linear speed. Well, picture is worth at least a couple of words. Here's a record. The center and the fly is about 5 centimeters from the center. So the R is 5 centimeters. If the record is rotating around in the counterclockwise sense, that's going to be a positive rotation, and the omega here is 33 1/3 revolutions per minute. And I want to find the linear speed of the fly, and that's going to go along with the v sub t. So that's the tangential component of the velocity, but it's going to be a positive number and it will match up with the speed just fine. Now, all we really need is to make use of the Vt equals R omega. But there's a problem. This requires radians. If we look at the R, 5 centimeters, well, surely we want SI units, so we could change that to 0.05 meters. But also this omega, 33 1/3 revolutions per minute, we can convert that to radians. And in fact, let's make it radians per second. No, I think since the problem doesn't specify, we could just leave it in minutes and take that for our final answer. But we definitely need the radians. So the revolutions into the radians, and 1 revolution is 2 pi radians. With cross cancellation, the revolutions will cancel. And this gives us an omega of about 209.4 radians per minute. And then the Vt, the linear velocity or linear speed, will be 0.05 times 209.4, which is just about 10.5 meters per minute. So the fly may really think that he's going places, but if he looks around, he may realize that he keeps coming back to the same spot over and over again. I don't know if he's going to worry about that.